Hey guys, hi, welcome to the session. So, this is Padma Tejaswi, and I have done my master's in chemical engineering from NIT Rourkela. So, I hope you guys are doing well. Yeah, I will be teaching heat transfer for GATE chemical engineering students. So, this session is for both chemical and mechanical engineering students. Okay, so yeah. I hope the session is useful for both chemical and mechanical students. So, this is a quiz analysis session basically. So, this quiz was conducted on like in the middle of the first course, heat transfer course. So, yeah, I have started a course for both heat transfer, in heat transfer for both chemical and mechanical engineering students. Okay, so yeah. So now I'm taking the quiz analysis. So if you want to attend the quiz, and there is another quiz also as a part of heat transfer. So if you want to attend the quiz, you can take the plus subscription by using my code Padma10. Okay, so if you use my code Padma10, then you will be getting a 10% discount on on subscription package. Okay, so yeah, do use the code and enroll for the course, and now you can have weekly quizzes, and as similarly now this is like a doubt clearing session or quiz analysis session, right? So you can also have sessions like that, and yeah, so it will be helpful for. Okay, just a minute. Yeah, so it will be helpful for you. Now, let us get into the session. So, now what we have to do is first question is the critical radius of insulation of a cylindrical pipe can be given by. So, this is a basic question, and this is a very simple question. So, yeah, how we will be calculating critical radius of insulation? So, what do you mean by critical radius of insulation? So at this point, what happens is, if if we are okay, so if we are insulating a pipe with like more amount of, if we are increasing the radius of thickness of insulation or radius of insulation, then what happens? So till RC, even though you insulate the material, because of the properties, the heat losses will be increasing. Okay, so even though if you increase the heat transfer, so while you are increasing the radius of insulation, what happens? The heat transfer area which is available for convection will be more, and because of this heat losses will becoming maximum. But when you reach this point, what happens is the heat losses will be maximum at a particular radius which is called critical radius of insulation. Okay, and after that when you increase the radius, what happens is the heat losses will be decreased. Okay, so whenever you are insulating a material, so you should check about this option. Okay, so you should check that the radius of insulation should be greater than the critical thickness of pipe. Okay, but if you are insulating a pipe with radius less than RC, then heat losses will be increased. Okay, so yeah, the correct option for this, the correct answer for this question is R is equal to K by H. So I will just explain you how the process is, like the how you'll be calculating this. So here what you do is we have to differentiate the resistance of the whole pipe, means after insulating what is the resistance to the heat transfer, whatever the resistance that is there should be equal to 0. Okay, so if you follow this step by step, you will be getting the answer. So I will just explain you what is the resistance that is there in a pipe. So let us suppose that we are having a pipe and we are insulating this. Okay, so we are insulating this. So what is the heat transfer, the mechanisms of heat transfer in this process? So whether it takes conduction or whether it takes convection. So through the insulated pipe, it will go through conduction, right? As this is a solid, the heat transfer mechanism for particles where there is no movement of molecules is through conduction, right? So it through the pipe it will be through conduction, and from the fluid to the wall it is through convection, right? Because there will be movement of molecules in the fluid, right? So the heat transfer that is taking in this place is conduction plus convection. So, what is the law that is corresponding to the heat transfer through conduction? It is Fourier's law of heat conduction, right? So, by using Fourier's law of heat conduction, Q is equal to minus Ka into dt by dx. So, this should be derived for cylindrical case. So, for cylindrical case, the thickness of pipe is dr, means the along which the heat is flowing is to the radius. So in radial direction the heat is flowing. Okay. So it will be dr and area is 2 pi rl. Okay. So if you integrate this equation, you will be getting like resistance as, so resistance for conduction will be ln of r2 by r1 by 2 pi kn. Okay, so this is the resistance for conduction process. And similarly for convection, what we have, Newton's law of heat cooling. It is Q is equal to HK into delta T. So here it will be 2 pi RL. And what is this two? What is this here area? It is the whole area, means H into 2 pi R2L. Okay, because convection will be occurring from the outer layer of the pipe to the fluid, right? Means ambient air, right? So through this is, so what will be the radius to the outer pipe? It is along with the insulated, right? So R2, so you should summation of these two resistances. So here resistance will be 1 by H into 2 pi R2 into L. So this is the convective resistance. Okay. So here the summation of resistances, so we should differentiate this equation with respect to 2, and this should be equal to 0. So whatever the answer that you are getting for radius will give you the critical thickness of insulation for this process. Okay. So it is R is equal to K by H. So I guess this is clear. So do solve it, and this is a very simple calculations. So but don't confuse R2 with R1. Okay. So here R2 is variable and R1 is constant because pipe radius is already fixed, right? But we will be varying the radius of insulation to know whether at this point we are having critical point or not, right? So R2 is variable and R1 is constant. So by using differentiations, you will be able to solve this question very easily. Okay. So second question. This is a very basic question. What is Grashof number? So what is Grashof number? It is defined as the ratio of buoyancy forces to the viscous forces. So option 2 is the correct answer. Okay. And Grashof number can be given by, so what is the formula for the Grashof number? It is GR is equal to G beta rho square L cube into delta T by mu square, right? So this is the Grashof number where G is gravitational constant and the density length of the pipe and the temperature difference and viscosity. Okay, so these are the terms that we have in Grashof number. But if we have a ratio of inertial force to viscous force, then what is so what is this dimensionless number? It is Reynolds number, right? So here we have rho du by mu. So if we are having a ratio of inertial force to viscous force, it is Reynolds number, and if it is buoyancy force to viscous force, then it is Grashof number. Okay, so it is a very simple question, and yeah, next one. So here we have at steady state the temperature variation in a plane wall which is made of two different solids 1 and 2 as shown below. Okay, so we are having this condition where we are having first wall at I mean the temperature gradient with first wall is shown as a with slope, let us suppose that with slope s1 and here slope is s2. Okay, so this is a rectangular slab and they are of same length L. So the thickness of the slabs are the same, but we want, what do you want? Then the conductivity of the material 1. So we should compare conductivity of the material 1 and 2 with respect to the graphs that they have given. Okay, so how we can compare it from the graph or from the given data? How we can say? One thing with which we can say or we can solve this question is by comparing the slopes of the two states. Okay, so here the slope is like somewhat more steeper, whereas the slope of when compared with the slope of the second state, right? So based on the slope value we can calculate, I mean we can decide conductivity of the materials, right? So for this we use what is the law that we can use here? It is Fourier's law of heat conduction, right? So Q is equal to Ka into dt by minus Ka into dt by dx, right? So here temperature gradient, right, which is nothing but the slope. So what they have given, they have they have said that it is a steady state temperature, right? So at steady state what happens? The amount of heat that is getting transferred in this slab is equal to the amount of heat that is getting transferred within this slab. So we can also say that the heat that is lost in this slab is the amount of energy that is transferred in this slab, right? So Q by A will be constant. So basically K is inversely proportional to the temperature gradient, right? So with this, what we have here, we have temperature versus distance, which is nothing but x, right? So the this relation will be giving you the slope of t and x, right? So what is the relation between the slope and the thermal conductivity? It is inversely proportional to the slope of the slope between temperature and x, right? So here slope of first first slab is greater than slope of second slab, right? Yeah. So because of this, what we have, as the slope of first slab is greater than slope of second slab, thermal conductivity of first one will be less than the thermal conductivity of second slab, which means the first slab will have less conductivity, means as compared to the second slab it will allow less amount of heat to get transferred through the first slab, whereas second slab will allow more amount of heat to get transferred. Okay, so the correct option is conductivity of material 1 is smaller than that of 2. So first option is the correct option. Okay, so yeah, this is the correct answer. And let's go to next question. It's a very simple question, right? So if you know the relation between thermal conductivity and slope of the material, then it will be very easy to solve this equation. Okay, so now we have yeah, a thermopane window which consists of two sheets of glass, each 6 mm thickness. So, sorry. Okay, so we have two sheets of glass, each 6 mm thickness, which are separated by a layer of stagnant air, which is also 6 mm thickness. So, yeah, let us suppose that we are having air over here. Okay, so this is 6 and this is 6 mm and this is also 6 mm. Okay, this is solid and this is air, and this is also solid. Okay, so we are having arrangement like this, and find the percentage of reduction in heat loss from this pane as compared to that of a single sheet of glass of 6 mm thickness, and the temperature drop between inside and outside remains constant, and it is at 15 degrees centigrade. Okay, so here what is the and thermal conductivity of the glass is 30 times that of air. Okay, so we have relation between thermal conductivity of air, and so thermal conductivity of glass is equal to 30 times of thermal conductivity of air, right? And we have temperature inside and outside remains constant. So overall temperature difference is 15 degrees centigrade, right? So we have this one. So first case is with two sheets of glass, and in between we will be having a layer of air. And the second case is we'll be having only one sheet. Okay. So we'll be having only one sheet, and the overall temperature difference here also 15 degrees centigrade. So for this case, the heat will be transferred through this window, which is through conduction, right? So here what will be the overall heat transfer? Q is equal to delta T by X by K. Q by A, heat flux will be this one, right? And for here, so first through this solid it will be through conduction, and from in this air it will be through convection, and in this solid it will be through conduction, right? So yeah, okay. um what will we have now? Okay, find the percentage of reduction hot in heat loss. So what you should do, the percentage of reduction will be 1 minus of q of second case, sorry, q of first case by q of second case. Right? So what will be the q of first case? It will be delta T by resistance through conduction plus resistance of convection plus resistance of conduction, right? So the resistance of conduction in both the solids, in both the sheets will be the same, X by Ka. So you can write it as 15 by 2 times of X by K plus convection. So through convection it is 1 by H into L, right? This is equal to the heat flux. So from this we have, yeah, if you calculate the resistance in this process, so and if you substitute the values that we have given, you will be getting the answer. So this is a very simple calculation, right? Delta T is the same in both the cases, and we have X by K, and here also we have X by K. So from this 1 by HL also we have, and yeah, what they have given that thermal conductivity of glass is 30 times that of air, which means, okay, so here they have given that it is a stagnant air, right? So what happens? So what is the difference between stagnant air and convection? In stagnant air, what happens? There is no movement of the gas molecules, right? So as there is no movement of gas molecules, we shouldn't consider the process, I mean the heat transfer mechanism through the air as convection. It is through conduction. Okay. So here also X by K of air. Okay. So it should be X of air by K of air. So it is not through convection. So here in air it is also through convection. So see, based on this question, like based on this term, like layer of stagnant air, the question is changed. The heat transfer mechanism in this process got changed, right? So you should be very careful while reading the question. So if you miss this term like stagnant air, then if you miss that, then you will not be able to solve this question. Like you will be searching for heat transfer coefficient, right? So that is not possible. And yeah, so please remember that if we are having a convection term, then you should see that there should be movement of molecules. But if there is no movement of molecules and if it is stagnant, the heat transfer in this process should be through conduction. Okay. Yeah, so solve this question by substituting these values. We have kg conductivity of air is equal to kg by 30. So substitute k is equal to k by 30, then you will be getting 30x by k, right? So on calculating, on substituting these values and calculating, you will be getting percentage of reduction as 96.9%. So which is almost around 97%, right? So first option is the correct answer. See, this is a very simple question. Only you should take care of that layer of the stagnant air, right? So if you find that, you will be solving this question very easily. Okay. So yeah, next question. I guess you are clear with this. So if you have any doubts at any step, like why we have taken conductivity as, through air also, why we have taken thermal conductivity. So please do comment. Then I will tell you the answer. Okay. I will elaborate or I will explain the answer again. So next question. In the pipe flow, heat is transferred from hot wall to the liquid pipe. Okay. So we are having a pipe flow. So let us draw a pipe. Okay. And inside we are having a fluid. Let us suppose that this is a fluid. Okay. So heat is transferred from hot wall to the liquid pipe. So from hot wall, let us suppose that we are having a, this is a wall. Okay. Then, so from this hot wall to the liquid, what is the heat transfer mechanism? So options, convection only, and conduction and convection, and none of this. So how can you say that? Here they are saying that there is a pipe flow, means flow is occurring. So there is a movement of fluid. So obviously when there is a movement of fluid, it should be through fluid, it should be convection, right? And the heat should be transferred from hot wall. So from hot wall to the fluid, it will be through conduction process, right? Because along the wall, it should be through conduction because there is no movement of molecules. So it will be conduction plus convection. Okay. So option C is the correct answer. If they ask only about what is the heat that is transferred in the hot wall, then it is only through conduction. Okay. So, and if they say that the fluid is stagnant, then it will be only through conduction because as the fluid is stagnant, there will be no movement of molecules inside the fluid and inside the pipe, and yeah, through the solid also it will be through conduction. Okay. So please be careful with the question. So read the question and understand it, draw the diagram, write the terms, and then only solve the question. Okay. So if they give like conduction and free convection as an option, and fourth option as conduction and forced convection, then what will be the correct answer? Post convection means here the convection the heat transfer through convection takes place only if we supply energy or if you supply external energy. Okay, but here what happens? They have mentioned that it is a hot wall and the heat is transferring from hot wall to the liquid, right? So there is no need of there is no need of using any external energy for this heat transfer. So because of the temperature difference, the heat will be transferred through convection easily. Like, so it will be conduction and free convection. Okay. So again in in convection also we will be having two terms. It is free and forced. Okay. So based upon the question that they have given or based upon the condition, you have to answer it. Okay. So yeah, next one. So I hope you are clear with all these questions. So if you have any doubt in any question, just comment. So I will be able to clear your doubts. Okay. Now, thermal conductivity is minimum for. We have silver as an option, we have chrome, nickel, steel, and we have aluminum and carbon steel. Okay. So yeah, I'm taking a course like heat transfer. The name is complete course on heat transfer as a part one in Unacademy app for GATE students. So if you want like more clear explanations, and if you want more information about this thermal conductivity and the laws which heat transfer for different mechanisms cover, so do log into the session. And yeah, first of all you have to take plus subscription, then you will be able to attend my course. Okay, so there I have taken a session on thermal conductivity, like how thermal conductivity depends on what properties it depends. Okay, so by using one of the properties we will be able to answer this question, because everyone will not know like the exact values of silver, aluminum and carbon steel, right? So basically, the order followed by like depending upon the physical status, conductivity of solids is greater than liquids is greater than gases, right? So solids will have the highest thermal conductivity, but in the options we have all as solids, right? And again in solids we have discrimination as pure metals will have highest thermal conductivity, and whereas impure metals will have low thermal conductivity. Means if you are having more number of alloys included, and I mean if you are including two or three metals in a material, and if you are forming a new material from that, then the combination of materials or combination of alloys, thermal conductivity of this alloys will be less than that of pure metal. Okay, so why we are saying this for alloys thermal conductivity will be less? Because in alloys what we are doing, we are mixing materials which are having different properties, right? So if we are 1, 2 and 3 are the materials, okay? And K1 is greater than K2 is greater than K3. So the thermal conductivity of the pure species K1 is greater than K2 is greater than K3. And but what we are doing? We are mixing these three metals. Means we are decreasing the thermal conductivity of first material, and we are mixing impurities which are having less lower thermal conductivity than the first material, right? So because of this, when we are having alloys, thermal conductivity will be very much lesser than the pure metals. Okay, so from this option you should select alloys which are having more number of mixing. Okay, so here we have chrome, nickel and steel. It is carbon steel, it is aluminum and silver, right? So these are different forms of carbon but here we have chrome, nickel and steel, right? So as this is an alloy, the conductivity of chrome, nickel and steel will be less than silver, aluminum and carbon steel. Okay, so yeah, I guess you are clear. Now let us solve another question. So what we have, yeah, we have the advantage of using a 1-2 shell and tube heat exchanger over a 1-1 shell and tube heat exchanger. So what this 1 and 2 represents? 1 means number of shell passes, okay, and 2 means number of tube passes. Okay, right? So from this like if you are having more number of shell passes, means if you are having 2 shell passes and 2 tube passes, then it will be 2 tube shell and tube heat exchanger. Okay, so they are asking about the advantage of using a 1-2 shell and tube exchanger over a 1-1 shell and tube exchanger. So 1-1 shell and tube heat exchanger means we are having only one shell pass and one tube pass, means the fluid will be entered into the only once through the shell and will be entered through the tube only once, right? But in 1-2 shell and tube heat exchanger, the tube can be, so the pass through which the number of passes through tube is 2, means it will be entering like this and again it will be entering in the opposite direction also, right? Means the liquid is allowed to get in contact with the hot fluid 2 times, right? So because of this what happens? More amount of heat transfer will be occurring in the tube side, right? So because of this, higher tube side heat transfer coefficient will be the advantage of 1 2 shell and tube heat exchanger over 1 1 shell and tube heat exchanger. Okay, so yeah, this is the correct answer. Okay, I guess you are clear with this, and we are left with two questions. So yeah, another question. What we have, a metal wire of 0.01 meters diameter and thermal conductivity is given. It is exposed to a fluid stream with a convective heat transfer coefficient of 1000 watts per meter square Kelvin. So H is equal to 1000 watts per meter square Kelvin, and yeah, diameter is equal to 0.01 meters, and what we have, conductivity. Conductivity is equal to 100 watts per meter Kelvin, right? So Wyatt number is nothing but HL by K, right? So, and this L is characteristic length, which means volume by area, right? So volume of, it is a cylinder. Wyatt means we can compare this with a cylinder, right? So with this, for the volume of the cylinder is pi r square h by 2 pi r h, right? So from this you will be getting r by 2. So characteristic length is nothing but r by 2. So calculate this value, and yeah, substitute this r by 2 value over here. Okay, so from this we'll have Wyatt number is equal to 1000 into diameter is 0.01, right? So which is 2 by 2r, right? So we'll have r is equal to 0.0025 by 2, which is the characteristic length, by, yeah, what we have, by k. Conductivity is 100, right? So it will be somewhere around okay. So by solving this, you will be getting the answer. Okay, sorry. This is 0. Okay, 2r is equal to 0.01, right? From this, r is equal to 0.005. So 0. And again r by 2 value will be 0.005 by 2, which gives 0.0025. So that is what we have written here. So from this, Wyatt number will be equal to 0.025. So the correct option is first option. Okay. So yeah, this is how we'll be solving this question, and yeah, I guess you are clear with this. So if you are having any doubts in the quiz, then post your doubts over here. Okay, I hope you are clear, and if you like the session, do promote it, and yeah, share it with your friends. Okay, so have a good day, guys. And if you like the session, and if you want more information about the heat transfer, and we also and have also launched like thermodynamics part 1, part 2, and part 3. Okay, so if you want to learn more, and if you want to concentrate on like particular topics, then yeah, do use my code Padma10. Then you will be getting a 10% discount for plus subscription. So what are you waiting for? Do use the code and take the subscription. Okay. Thank you so much for the session. And yeah, do share it with your friends. And if you like it, give a big thumbs up. Have a good day and prepare well for the exam.